Report, where we uncover what's working and what's breaking on the internet and why. Today, I'm joined by Kemal Santja, and today we're going to talk about the Microsoft outage that happened on January 25th, 2023. So it was a very significant outage that at its peak, or during the majority or the most significant portion of the outage, lasted about 90 minutes, but we saw residual impact for more than 5 hours. So we're going to dive into that and first talk about what happened. So Kemal, take it away.
Thank you, Angelique. This was most certainly a very interesting event. As part of we observed quite large-scale impact that affected various Microsoft services. Now, looking at the event and based on what Microsoft already provided information on when it comes to their limited root cause analysis, or RCA, it looks like at 7 a.m. UTC, there was a spike in BGP events that quite significantly affected them. Looking one data point before that, you can quite clearly see on the left-hand side where our BGP collectors are that Microsoft Corporation Autonomous System 8068 is advertising their prefixes to their backbone ASN, which is 8075. And as indicated with green color on the left-hand side where our BGP collectors are located, you can see that prefixes are getting advertised and propagated the way it's usually working when everything is working fine. However, if we navigate into the event itself, looking at these various internet BGP collectors, you can quite clearly see that they've changed the colors. All of a sudden, they are all red, or they are orange or yellow, indicating that something quite significant happened. Also, that's quite clearly indicated in our interface by the fact that we can see a lot of red striped and solid lines, as part of which they mean that either the prefixes got installed or the prefixes got withdrawn. Now, looking at this particular collector, if I navigate over that collector and I can click on show only in this monitor, that's going to kind of declutter the view to a certain degree. And on the timeline, we can see that metric is path changes, or essentially we can select updates, and we're going to observe very similar pattern of the events on the timeline. As part of which, it's kind of obvious that there were certain advertisements at the time from Microsoft ASN 8075, which is their backbone ASN. If I hover over this collector and I click view details of the path changes, we can see that approximately at 7:12 or 7:10, depending on the collector itself, UTC, Microsoft started advertising these prefixes, but this time with a longer ASN path, autonomous system path, as part of which they installed transit providers instead of their direct peering with companies where our BGP collectors were located, which is quite interesting behavior in itself, because BGP works with something that we call BGP best path selection algorithm, which is the algorithm that BGP uses to calculate the best path that's going to get installed in forwarding table. Usually, it's being done by the BGP attributes that are advertised along with the prefixes that the BGP speaking routers are advertising. And one of the first attributes is so-called autonomous system path. And the shorter it is, the better it gets from the visibility. Now, if you take into consideration that fact, installing of the longer AS path is kind of interesting. And now we can see certain level of volatility in this particular event, as part of which we can see that at 8:12 for this particular, or 7:12 UTC for this particular collector, this particular event, as part of which we kind of transitioned through two different transit providers before installing the direct peering, we can see it repeating several times. And that kind of continued, and we can see that that lasted some more time until approximately 8:22 or 7:22 UTC, and we can see that there was a lot of routing table churn. Now, obviously, these kinds of events are going to be impacting on the from the customer perspective. And in this particular case, we saw the impact in the form of large amounts of packet loss, which we are going to touch base on a little bit later on. The other interesting thing that happened as part of this event is the fact that it affected summary prefixes as well. Now, summary prefixes are covering prefixes for these smaller prefixes. And in this particular case, we are looking at /12. And we can see that BGP updates were happening for them as well. Now, exactly the same thing happened, which means that they were initially withdrawn from the routing table, and then later on re-advertised over the transit, ultimately settling on path using direct peering, the shortest ASN path one. But it's quite interesting to see that actually this event affected them as well. Now, given the fact that everything here is happening on /24, and we are focusing on /24 due to the fact that these are the most specific prefixes that are accepted on the internet, we can see that this went from 8:10 or 7:10 UTC until 7:22. And then between 7:22 and approximately 7:40, there was a brief period of stability as part of this, like between 7:22 and 7:42. There was a period of stability as part of which this kind of settled down, things calmed down, but then again, it kind of restarted. And then it continued some more as part of which we are seeing installation of these prefixes, withdrawals of these prefixes over the transit providers, ultimately settling down at approximately 8:45, which means that there was a packet loss that lasted for about 90 minutes, but residual effects of this change continues for several more hours. Now, if I click on the path visualization for this particular event, you can quite clearly see that there was a lot of red color on our timeline. And our red color in the timeline indicates that there was an elevated packet loss during this event. Now, if you think about it some more, you're going to quite quickly observe that, these elevated amounts of packet loss quite closely correlate with the spikes in route advertisements that were observed by Autonomous System 8075. Which means that a lot of connections were being teared down. People had problem establishing connections towards these services, and there was overall negative experience for Microsoft larger customer base. Packet loss is never good indicator for the service. Essentially, what that means is that even a small amount of packet loss is going to have a pretty significant negative effect on the throughput, as part of which, if I navigate to our HTTP server view, we can quite clearly see that there was a significant dip in a metric that we call availability. And availability in our case is nothing else than ability to do DNS resolution, which is essentially ability to translate domain name into IP address. Connect is first step in establishing any kind of TCP connection, which is essentially three-way handshake. Then you can see that some of our agents actually failed to establish, to negotiate SSL. Some of the agents had problems in receive phase, which is essentially they were not able to receive traffic within the dedicated 5 seconds interval. They were not able to receive the traffic from Microsoft. And then HTTP is essentially what we were getting from the Microsoft's HTTP servers. In this particular case, if I click on table, you are going to see that some of their services at the time when this was happening were returning 503s, but majority of the other agents that were executing this were timing out in receive phase, or there were kind of DNS issues, or they were not able to establish TCP connection, indicating that this was a pretty large-scale negative event. As you can see here, majority of the impact actually happened during these first 90 minutes of the event, but residual negative effects continued for hours after the event, ultimately later on settling it. Now, Angelique, one of the interesting things that we observed over the weekend was the fact that Microsoft published RCA, or root cause analysis. Could you tell us a little bit more about that?
They published a very interesting RCA. It's preliminary, but it actually had quite a lot of detail that's very interesting, and we'll discuss that. But before we get into that, I just wanted to ask a quick question about the rapid announcement changes that we were seeing. So we were seeing a lot of stability issues in terms of the routes that were installed in routing tables across many different service providers. So why would that cause packet loss at the scale that we saw?
So essentially what happened is that there was a lot of churn. So every time you re-advertise the prefix, BGP essentially does that through the method of sending update packet, which contains something that we called NLRIs, or network layer reachability information, that's tied with these BGP attributes that I talked about. So every time receiving router gets the update, it needs to look into that, figure out whether that's an update worth considering, so to say, and then it calculates new best path based on that information. Now, sometimes in these updates, you're going to see the withdrawals. Sometimes there are going to be new prefixes, but BGP protocol needs to examine every single one of them, and that's a very CPU intensive task. So now, if you look at this event that we just talked about, there was a lot of volatility in terms and rapidity in how often these new providers were being installed. So as you can imagine, Microsoft is quite popular. These services such as Outlook, SharePoint, and various Azure services and stuff like that are quite popular. So every time that happens, quite a large number of traffic gets redirected on the different networking path between source and the target being Microsoft in this particular case, and then that particular path gets again tear down, as part of which you tear down a lot of TCP connections, and a new path is installed. That tied together with the fact that services themselves had a problem, responding to legitimate requests during this time, it's going to reflect in this much of packet loss. Now, the other thing is, the other thing that I would like to touch base on in this particular case is this, length of the event. Now, we are seeing about 90 minutes of core event plus residual effects of the event itself. You have to take into consideration that this is pretty large scale issue that happened during this time. And as you can imagine, various network reliability engineering or service reliability engineering teams were probably paged during this effect for, impaired services. And if you take the scale of the issue, and given the fact that it was a global problem, we need to be empathetic towards the Microsoft engineering team. This was pretty significant. I myself consider myself network engineer, even though I'm not in the trenches anymore on a daily basis. But I had experience as part of which I was on the originating side of outages similar to this one, unfortunately. People are going to panic. You do not want to believe that the change that you are doing is the one that caused this, right? So you're going to triple check that it's not your change. You're going to start troubleshooting. Various teams are going to get into troubleshooting mode. There's going to be a probably call spun up with the call leader, as part of which everyone is trying to figure what's happening. So there's a lot of uncertainty in these kinds of events and stuff like that. So overall, 90 minutes of events such as this one, given everything that was at stake, and by trying and ensuring not to cause any more harm than there is, it's a pretty good response. That's what I'm trying to say.
Yeah, well, I mean, just on that, in terms of what the cause was. So Microsoft stated that the trigger essentially for this issue was the attempt to change an IP address on one of their routers. Now, that seems like something fairly mundane in terms of an update. So why would something like that have had this effect where effectively globally, we saw a massive connectivity disruption? So can you kind of describe how would that actually work? Why would something so simple, it would seem, cause such such havoc?
Yeah, that's actually quite a good question, and we can only speculate from this perspective, given the fact that we know what they were trying to do. Unfortunately, we don't know too much about the design and architecture of the network. However, thinking about this particular event, there are a couple of theories that might have happened during this time. Now we know that it was a IP address change of one of their WAN routers on one of their WAN routers that had a cascading effect, as part of which it originated a lot of messages that other routers were dealing with. Right now, if you think about it, usually when it comes to BGP, connections are established in what we called full mesh. Essentially, every single router is linked and speaks to every other router in the network topology. That's essentially a full mesh topology. However, given the Microsoft scale and in general inflexibility of full mesh networks, people tend to do or tend to use something that we call route reflectors, as part of which you establish BGP sessions towards specific routers in your network that are also BGP speaking routers that are re-advertising prefixes based on certain criteria to the rest of the network, ultimately giving you ability not to full mesh with everything. So essentially, you decrease, you to a certain degree decrease the complexity of your network. However, at the given risk of, if you lose that particular router, and that router does not have redundancy, which I don't believe was the case in this particular Microsoft's case, you might end up with outage. Right now, just from the experience of being network engineer at large-scale companies, I can tell you that I've experienced similar issues, as part of which any kind of networking change that would affect route reflector that's really busy, that's receiving thousands or at this day and age, right, millions of prefixes from all other transit and peering routers, would cause something like this. Essentially, what happens is that it relays the message to everything, to every single other BGP speaking router, depending on the topology. That might be hundreds of routers, if not more. And then all of a sudden, like, BGP best path selection algorithm starts its work to identify whether there are new best prefixes. And that's going to cause a lot of CPU related work. And based on this preliminary RCA from Microsoft, it looks like essentially something like that happened, right? As part of which there was an event, the IP address change, that caused other routers to recompute paths, which means for the given period of time, there was potentially some amount of black holing of the traffic. Like, essentially, maybe the prefixes were withdrawn, or the routers were trying to send the traffic to the paths that were not in operation any longer. Right now, in general, for regular enterprise companies, that should not happen, right? Like, these changes are very quick and swift, and usually when it comes to that, they're going to work fine. However, if you are at the scale at Microsoft or Google or Facebook or other large-scale company, which receives like millions of different routes, to different, who knows how many transit providers, direct peerings and stuff like that, things can and does get more complicated, right? So that's one of the things. Like, maybe they were trying to change some IP address on really busy route reflector, which had a negative cascading effect on other routers, as part of which there was a lot of CPU utilization spikes and stuff like that on their infrastructure. Routers which were trying to send traffic on the paths that are not in the function anymore, ultimately black holing the traffic, right? That's one of the things that could be potential issue. The other one is, it's 2023, people are using SDN. It's not just like, net marketing term any longer. Actually, people did develop solutions and they are working fine. So one of the scenarios that could have potentially happened is that Microsoft had some kind of controller device that's responsible for installation of proper prefixes, or informing the rest of the network that which prefixes and where should be installed. And if you kind of nuke that device by change such as this one, you might end up in a situation as part of which your central intelligence is lost, as part of which network goes into flux states, which might explain what we saw. Now, which of these theories is what happened, we don't know, or whether any of these theories is what happened. But both of these theories about what could have happened actually are possible. So that's what I think about this.
Yeah, I mean, I think what was particularly interesting about this incident was that initially it wasn't clear where the problem was. So obviously there was a lot of customers, both enterprise customers as well as just regular users who might have been trying to connect to various applications and services hosted within Azure, and may not have initially understood where the problem was. They might have thought it might have been an application issue, or maybe like a configuration issue to do with a particular application, for example. But almost immediately, we saw that this was very clearly network related, and very clearly this was related to announcements that were being made to Microsoft peers, and then of course like the impact that was having. So is there something to be learned from that in terms of how enterprises and IT operations professionals approach how they determine what's happening, again, in the absence of maybe immediate information from the provider who obviously is going to be very busy troubleshooting an issue rather than maybe communicating details?
Of course, there are many lessons, but even before we go there, what I wanted to mention is the fact that based on some of data that we were looking at ThousandEyes, as part of which we were analyzing, detecting, reporting about similar issues. It's not just Microsoft. We are doing this for enterprise customers of all sizes, right? In this particular case, as I mentioned during the demo part of this talk, we saw this on large summary prefixes, right? And there is one pattern that actually kind of gets shaped. As part of it, looks that around 740 or something like that, Microsoft kind of tried to roll back the change. Now, if you take into consideration any of the theories that we just spoke about, if you roll back the change that caused all of this churn, you're gonna re-churn again. Right. Essentially, what's going to happen is like you take that loopback or IP address of that router, and you change it to something else. You observe the issue for some like 40 minutes. You are trying to identify what happened. You identify the change. The natural instinct of engineers, network engineers, is, in this particular case, and any kind of like business person, is like, let's roll it back. And if you roll it back, you're going to cause exactly the same effect again. All of these routers that that were affected are going to get affected again by the potential IP address rollback, because they need to relearn the prefixes. Advertisements are going to go and so that might explain why we also saw like this event happening for as much as it did. But to your point, one of the lessons that everyone needs to take from this event is that visibility is a paramount that everyone should strive, regardless of whether you are, a service provider such as Microsoft in this particular case, or you are using application that's potentially hosted as a SaaS application. So for example, if you are using SharePoint or Outlook or something like that, and you're wondering whether it's your network or some, your provider's network, it would have been pretty easy to identify where the issue is, and in 2023, I believe that it's kind of tragic if you are learning about these issues by your customers. So that's completely unacceptable at this stage and age. So, regardless of what is it that you are using, you should really strive towards the, proper visibility, as part of which you can make your own decisions, remediation steps, and stuff like that. The other thing is, this outlines the fact that there's no such thing as like mundane change request. Like this was an IP address change. By any stretch of imagination, like, there's no scenario in which this IP address change could cause something like this, right? It's just not like something that you would envision. As part of change management procedures, usually engineers are being asked about, like, what are the steps that you're gonna take to limit the blast radius of this change? How can you envision that IP address change is gonna have this negative effect, right? It's super hard, right? This also speaks about, like, operational excellence, as part of which you really need to, take into consideration all possible scenarios, as part of which you need to limit the blast radius, maybe test it out in some kind of lab before you start or rolling back this. In this particular case, I'm pretty sure that would be really hard given the scale. This would not have happened at scale. But for many companies, like these kind of changes, you would capture them. And one of the things is, like, many of these changes these days are executed by automation. So you should really have some sort of automation or audit that's actually measuring the impact of your change. So it should be a kind of blocking audit, as part of which, you do something, you observe the impact, and, if there's like impact above certain percent of maybe packet loss, or there's a spike in latency or something like that, there should be automation that uses that blocking audit to, either roll back this change or stop you from executing it further until things stabilize. So, I'm speaking here strictly as a network engineer. I'm pretty sure that from the business perspective, there are many other lessons that people can learn, but, from the network engineering trenches, these are some of the things that could be done.
Yeah, absolutely. Those are great ones. So is there anything that we should cover off for the event before we close out for today?
That would be everything from my side. Thank you so much, Angelique. It's been an absolute pleasure speaking about issues such as this one, and I hope that one of the lessons that our audience is going to hear is the one about the importance of visibility.
Yeah, absolutely. Thank you. This was really informative, breaking down the outage. So thank you again for joining us, and please subscribe and like our podcast. And if you do, we will send you a free t-shirt. So go ahead and do that and send us an email at internetreport@thousandeyes.com and provide your t-shirt size and your address, and we'll get that right over to you. So with that, thank you, and we'll see you next time.